So let us discuss about the problem on multi-cylinder engine. So the turning moment diagram for a petrol engine is drawn to the following scales. So here in every problem with respect to the multi-cylinder engine, the scale will be given. Why? Because if you see in the fourth line, the areas of the turning moment diagram are given. So we need to calculate the energies. So the areas can't be equal to energies. So he will give the scale. So the turning moment on x-axis 1 mm is equals to 1 degree, and on y-axis it is given as 1 mm is equals to 5 Newton meter. So in the next couple of minutes I will tell you how to use this particular scale which is given. So the turning moment diagram repeats itself at every half revolution of the engine, and the areas above and below the mean torque line given in order are 295, 685 and so on. So here the areas of the turning moment diagram are given, and moreover the rotating parts are equivalent to a mass of 36 kgs at a radius of gyration of 150. So he asked you to calculate the coefficient of fluctuation of speed. So coefficient of fluctuation of speed is denoted with Cs. So he has already given that the engine runs at 1800 rpm. So here the mass which is given as 36 kgs. So in the given data you need to write all the data which is given in the problem, and moreover the radius of gyration is given as 150 mm. You need to convert it into meters. The mean speed of the engine capital N is given as 1800 rpm. So we have the formula for angular velocity 2 pi n by 60. So substitute in that formula and you can get omega value as 188.52 radians per second. So in my previous video I have already told you that the diagram for a multi-cylinder engine will look like this. So draw a diagram like this. So no need to draw with exact values. So you can draw with a free hand. So here the values or areas of the turning moment diagram are given as 295, 685 and so on up to 270. So in some problems he will give you the positive or negative symbols for the areas, but here in this problem the symbols are not given. So start with the positive loop, so 295, followed by the negative loop 685, again positive loop 40, again negative loop 340, positive loop 960 and negative loop 270. So since he has not given any plus or minus symbols in the areas, we need to start with the positive loop followed by the negative loop and so on. So all the areas which are given in the problem are plotted here, and after plotting the areas give some terminology like ABCD and so on. For it, for the different points you give the naming as ABCD and so on up to G. So he asked us to calculate the coefficient of fluctuation of speed. So for every problem we need to follow the reverse order. Nothing but we need to start with what he has asked us. From that step only we need to start the problem. So he asked us to calculate coefficient of fluctuation of speed. So moreover in this multi-cylinder engine problems, we need to first calculate the fluctuation of energies. So in order to calculate the fluctuation of energies, we need to start by calculating the energy at every point. So please don't get confused, it is very easy. So the scale is given as 1 mm is equals to 5 Newton meter and 1 mm is equals to, so let us once have a look at the problem. So see, 1 mm is equals to 5 Newton meter and 1 mm is equals to 1 degree. It is given as the scale. So first we need to convert that scale into energy. So 1 mm square is equals to 5 into 1. It is given as in degrees, so we need to convert it into radians. So 1 degree is equals to pi by 180 radians. So pi by 180 into 5. which has come around pi by 36. So 1 mm square is equals to pi by 36 Newton meter of energy. So we will use this later on. So coming to the energy calculation, so the energy at A. So we don't know the energy at the starting point of the diagram, so let it be capital E. So energy at A is equals to capital E. And coming to AB, so the AB is nothing but the positive loop of area 295. So we have assumed that the energy at the starting point A is equals to E. So coming to the energy calculation at B, so we need to add the energy since it is a positive loop. So the energy at B is equals to energy at A, which is nothing but E, plus AB, we have the positive loop of 295 area. So E plus 295. So it is the energy at point B. So coming to the energy at C, so BC is negative loop, right? So we need to calculate the energy at C. So we need to calculate the energy at C. So since it is a negative loop, we need to subtract. So the energy at C is equals to energy at B, which is nothing but E plus 295 minus 685. So we have denoted minus symbol. Why? Because it is a negative loop. So E plus 295 minus 685, which has come around E minus 390. So E minus 390 is the energy at C. So coming to the energy at D, so CD is the positive loop. So in order to calculate the energy at D, we need to take the energy at the respective point C and we need to add the energy 40 since 40 is a positive loop. So energy at D is equals to energy at C, which is E minus 390 plus 40. What is 40? So 40 is the area between C and D points. It is a positive loop, so we have added, nothing but plus symbol is used. So E minus 390 plus 40, which is E minus 350. So like that, until point G, we need to calculate all the energies. So please remember, in any multi-cylinder engine, in the calculation of energies at different points, you need to get the energy at the last point. So what is the last point in this diagram? G. So energy at G is equals to, at last we have got capital E value. So if you don't get capital E value at the last point, nothing but energy at the last point must be equal to the energy at the starting point. So we have assumed that the energy at starting point A as E. So the last point is G. So energy at G should also come as E. So if it is, if it does not come E value for you, then at some point of calculation you have done a mistake, so please check it. So you should get capital E. So after getting energies at all the points, you need to calculate the maximum fluctuation of energy, for which the formula is maximum energy minus minimum energy. So out of all these energies, E plus 295, E minus 390 and so on, the maximum energy is E plus 295 and the minimum energy is E minus 690. So subtract those two energies, you will be getting 985 mm square, but energy should be in terms of joules. So already we have calculated the conversion factor, 1 mm square is equals to pi by 36. So please multiply your 985 mm square, which is fluctuation of energy, with the conversion factor pi by 36. So the area is being converted into energy. So we have got delta E as 86 joules. So we have the formula delta E is equals to mk square omega square Cs. So substitute the value of delta E. Mass of the flywheel is already given as 36. Radius of gyration is given as 0.15. Omega we have calculated. So by substituting all those values, we can get the value of coefficient of fluctuation of speed, which is 0.003. So like this, for every multi-cylinder engine problem, we need to calculate the energies at different points. We need to calculate the maximum fluctuation of energy, and by using the relevant formula for delta E, we need to calculate the values. So here in this formula, Cs value is being asked. So if he asks you the value of m by giving all other values, you can also calculate the mass of the flywheel. So these problems are very easy, so please don't leave multi-cylinder engine problems. Very easy to practice and score in the exams. Thank you.